Everything you think you know about the Ice Age is wrong. When most people picture this ancient world, they see endless white ice and perpetual darkness. The picture is messier and more interesting than the frozen wasteland image we get from movies. Large ice sheets covered major parts of the northern hemisphere, but vast regions stayed ice-free where tundra grasslands and sparse forests supported abundant life. These weren't barren wastelands. They were thriving ecosystems where massive herds of mammoths, mastodons, and giant horses roamed freely, where the summer sun could shine for 24 hours straight and warm oases provided refuge from the cold. We'll explore how ice sheets and ice-free zones coexisted, how giant herbivores shaped those landscapes, and why this ancient world matters more than ever today. But first, we need to expose the great deception that's been hiding in plain sight. Most museum dioramas and movies show the Ice Age as a planet-wide freezer, but geologic mapping and ice core records show something shocking about what Earth actually looked like 20,000 years ago. Walk into any natural history museum and you'll see displays of woolly mammoths trudging through endless snowfields under grey skies. Hollywood reinforces this image with films showing our ancestors huddled in caves surrounded by nothing but ice and desolation. This widespread misconception has shaped how we think about one of Earth's most important periods. The reality is far more complex and fascinating. During the last glacial maximum, major ice sheets, like the Laurentide and Fennoscandian, covered large northern areas, while a vast mammoth steppe of productive grassland stretched across Eurasia into Beringia, a contiguous wide zone of habitat rather than a single global ice sheet. Geological surveys and ice core data have mapped exactly where massive ice sheets existed versus where life flourished. The Laurentide ice sheet covered much of northern North America, while the Fennoscandian ice sheet blanketed Scandinavia and parts of northern Europe. But between these frozen regions lay something extraordinary. Scientists call it the Mammoth Steppe, a continuous belt of grasslands that stretched from Spain all the way to Alaska. This wasn't barren tundra, but productive habitat that supported herds of mammoths, horses, bison, and countless other species. This vast grassland ecosystem covered enormous areas across multiple continents. Orbital changes known as Milankovitch cycles paced repeated cold-warm cycles, so the Ice Age was a series of glacial and interglacial phases rather than one uninterrupted freeze. These orbital variations affected how much solar radiation different parts of Earth received, creating a complex pattern of climate zones. Regions like Beringia, the land bridge connecting Asia and North America, remained ice-free corridors teeming with life even during peak cold periods. Here, grasses and herbs flourished in well-drained soils, supporting dense populations of herbivores. The Ice Age was actually a complex mosaic of climates existing simultaneously across the globe. Arctic tundra dominated some regions, while temperate grasslands thrived in others. Sparse forests grew in protected valleys, and even desert-like conditions existed in certain areas. This environmental diversity created opportunities for life to adapt and flourish in ways that completely contradict our frozen wasteland imagery. But if most of Earth wasn't frozen, what was actually shaping these diverse landscapes day by day? Huge herds of mammoths and other mega herbivores had outsized effects on these landscapes, trampling vegetation, transporting nutrients, and dispersing seeds across vast distances. These massive animals functioned as ecosystem engineers, physically transforming their environments through their daily activities. Every step they took, every plant they ate, and every path they created had consequences that rippled across thousands of square miles. Here's the paradox that puzzled researchers for decades. How could massive herbivores maintain open grasslands instead of allowing forests to take over? The answer lies in understanding how these giants interacted with their environment. Researchers often compare mammoth impacts to those of modern elephants, large animals that maintain open habitats and redistribute nutrients, and evidence from pollen and fungal spore records supports that mega herbivores help keep landscapes open. Mammoths trampled vegetation with their enormous feet, creating disturbed soil patches where new plants could establish. Their dung served as mobile fertilizer factories, dispersing seeds as herds migrated seasonally and creating patches of enhanced soil fertility that supported diverse plant communities. Paleoecologists use dung fungus spores called Sporomyella in lake sediments to detect past mega-herbivore abundance. These records show megafauna did influence vegetation and that their decline often preceded vegetation and fire regime changes. But mammoths weren't the only landscape architects at work. Mastodons took a completely different approach to environmental modification. While mammoths maintained grasslands through their feeding patterns, mastodons actually promoted woody vegetation by browsing on shrubs and small trees, creating forest openings that allowed understory plants to flourish. Giant ground sloths and other mega herbivores contributed their own modifications through behaviors inferred from modern analogues and sediment traces. Ancient horses and bison added another layer of complexity through their sophisticated seasonal migration routes. These migrations connected distant ecosystems and spread nutrients across continents as animals carried minerals and organic matter in their bodies from one region to another. The seasonal timing of these movements created predictable pulses of disturbance and fertilization that many plant species came to depend on. When these landscape architects suddenly disappeared around 12,000 years ago, the effects were dramatic. Modern paleo studies link megafaunal collapse to increased charcoal from fires and shifts from open to more closed vegetation, a cascade clearly documented in multiple paleo records. Without their constant trampling, seed dispersal, and nutrient cycling, many grassland ecosystems transformed into forests or shrublands. But these ecosystem engineers didn't work alone in shaping the ancient world. In Florida, about 500 years ago, human hunters crouched beside crystal clear springs, crafting stone tools, while mastodons grazed nearby, a scene that completely redefines our understanding of early human survival. The Page Ladson archaeological site reveals exactly this scenario, where a stone knife found in the same layer as mastodon remains shows humans and megafauna coexisted in pine savannas and grasslands that stretched across prehistoric Florida. This wasn't a frozen wasteland, but a diverse landscape where intelligent humans were effective, adaptable competitors. Another predator in a multi-predator landscape, using tools, coordinated hunting, and possibly controlled fire to survive alongside large carnivores and mega herbivores. The assumption that humans were helpless wanderers struggling against impossible odds crumbles when we examine the evidence. These early people were skilled competitors in complex predator hierarchies, using intelligence and strategy to find their niche in ecosystems dominated by creatures 10 times their size. The Florida ecosystem, about 14,500 years ago, consisted of open grasslands dotted with longleaf pine savannas maintained by frequent fires and constant megafauna grazing. This created a parkland environment with excellent visibility and abundant resources. Pollen analysis reveals that humans lived in diverse habitats featuring grasses, herbs, and scattered woodlands rather than ice-covered wastelands. They strategically positioned themselves along rivers, ice margins, and resource-rich corridors to exploit changing environments as seasons shifted and animal populations migrated. These locations provided access to fresh water stone for tool making and predictable hunting opportunities. Humans developed sophisticated tools and hunting strategies to compete with cave lions, dire wolves, and giant hyenas for the same prey animals. They crafted specialized spear points and coordinated group hunts that could bring down massive herbivores. Evidence shows fire was common on the landscape, and humans could have used it strategically for cooking warmth and possibly to influence vegetation patterns. But the degree and methods remain a subject of ongoing research. Competition was fierce, but humans possessed advantages that other predators lacked the ability to plan complex strategies, modify their environment, and adapt their behavior rapidly to changing conditions. These dynamic ecosystems created perfect conditions for both human innovation and megafaunal diversity. The constant interaction between different species, the seasonal availability of resources, and the need to compete with formidable rivals drove technological advancement and social cooperation among human groups. Humans weren't passive survivors, but active participants in shaping Ice Age landscapes through selective hunting practices that influence vegetation patterns and animal behavior across entire regions. But this complex world offered more than just survival challenges. It created sensory experiences unlike anything modern humans have ever witnessed. The sound sites and seasonal rhythms of this ancient world created a sensory environment completely unlike anything we know today. High latitude summers brought near continuous daylight that stretched across endless grasslands, while winters delivered long dark nights and intense seasonal swings that shaped animal and human routines. At lower latitudes, the thin, dry air created crystal clear visibility that stretched for hundreds of miles across open landscapes, revealing brilliant blue skies that contrasted sharply with popular imagery of grey, gloomy conditions. The acoustic landscape would have been dominated by sounds no longer heard on Earth. Large migrations and the movement of herds made landscape scale disturbance and noise common as millions of hooves moved across hard-packed soil. The crack and groan of moving glaciers echoed across valleys as massive ice sheets shifted and fractured under their own weight. Giant animals called to each other across open plains. The trumpet of mammoths, the roar of cave lions, and the howls of dire wolves created a symphony that carried for miles in the clear air. Loess and charcoal layers in sediments show that wind-blown dust and fire were important forces shaping Ice Age ecosystems and skies. These fires weren't disasters, but regular events that renewed landscapes and created dramatic sunsets filtered through smoke and atmospheric particles. Glacial dust enriched soils while creating unique atmospheric conditions that painted the sky in colours that would seem impossible today. Seasonal variations transformed entire continents from the brilliant white of winter tundra to the explosive green of brief Arctic summers when plants rush to complete their life cycles in just a few warm months. Imagine a world of thunderous migratory herds, cracked ice, and smoky red sunsets after frequent grass fires, a sensory environment very different from a calm winter postcard. These intense seasonal contrasts shaped animal migration patterns and human cultural development in ways we're only beginning to understand through multi-proxy evidence from pollen charcoal and sediment records. This vibrant, complex world of dramatic seasonal shifts and rapid ecosystem changes holds lessons that are becoming increasingly urgent to understand. Today's climate research reveals striking parallels to those ancient transitions. Current climate change is creating vegetation shifts similar to post-Ice Age transitions. But what took 10 to 20,000 years after the last glacial maximum may be compressed into a century or two under current emissions scenarios, far faster than ecosystems evolved to handle. Since the last ice age, Earth warmed roughly 7 to 13 degree Celsius. Under business as usual scenarios, similar magnitudes of warming are projected within a few centuries. As forests replace grasslands and species migrate to new regions, we're witnessing ecological changes that mirror what happened when the great ice sheets melted. The difference is timing. What took millennia then is happening in decades now. Consider how our misconceptions about the Ice Age might extend to other prehistoric periods. Ancient ecosystems were far more complex and dynamic than popular culture suggests. The Ice Age's true legacy isn't frozen wasteland imagery, but proof of life's incredible adaptability during extreme climate shifts. If this upends your mental picture of the Ice Age, tell us where you pictured the mammoth, and hit subscribe if you want more myth-busting, deep-time science.